Here's 4.9, modeling with polynomial functions. Okay, I've got this data set here, and I first want to figure out what degree function fits this data. So what I'm going to do is look at the differences, the first differences, the second differences, and so on. So you need to make sure that your x's are evenly spaced in order to use this method. And they are here, 1, 2, 3, 4, 5. It doesn't have to be counting by ones. It could be counting by twos or threes or fours or whatever. But it has to be consistent how it's going in the x's. And it also doesn't have to start with 1. It could start with a negative number. So this could be 100, 200, 300, something like that, right, for your x's. But as long as the x's are evenly spaced, then you can look at the differences between the y's. Okay, so what I'm looking at is how am I getting from term to term by either adding or subtracting. So -4 to -2, I'd have to add 2 units, right? And then -2 to -4, I'd be subtracting 2. And then -4 to -16 would be subtracting 12. And then I'd have to subtract 28 from -16 to get to -44. You could take any number and subtract the previous number to get those differences. So I could take, -44 minus -16, and that gives me that -28 there. So take any number and subtract the previous term to get those, right? It would work on all these. -4 minus -2 would give you -2. Okay, so these are called the first differences, and you see I got different numbers out every time. So I would say that this does not have a common first difference. If it had a common first difference, if I got the same number out every time, then a first degree equation would fit this. So since that doesn't work, I'm going to look now at the second differences. Okay, and I'm thinking, how am I getting from term to term here? So from 2 to -2, I'd have to subtract 4. All right, from -2 to -12, I'd have to subtract 10. And from -12 to -28, I would subtract 16. Okay, so hey, this isn't a second degree function that fits this either. Now I'm going to check the third differences. And you can keep doing this test forever as long as you have enough data points. You can see pretty soon I'll run out of data points here, but I can check this once more to see if I get the same number out each time. Okay, so here I'd be subtracting 6 and subtracting 6. Hey, we got a winner there, right? So first differences, second differences. This is the third differences. So this has a common third difference. Which means that a third degree equation is going to fit this. And that's going to be, so third degree. And a third degree function is called a cubic function. Okay. And now we can use, there's a number of ways you can write a polynomial function. The easiest way to do it, I think, is using regression on a TI calculator. And I've taught this before earlier in the course, but we were only going up to second degree equations. Now we can go up to higher degree equations, but it's the same kind of deal, okay? So I want to put this data in my stored in my calculator, and I'm going to put it in the stat menu. So there's a stat button near the top middle, okay? And I'm going to go to edit. I'm going to choose the very first thing there, just hit enter. And then I've got some data points in there already. I want to clear those out. So you can clear them out one by one with the clear button, the data points. But if you go and highlight L1 and then hit clear and enter, then it'll delete the whole list. You can also write right over the old numbers if you have other numbers there. So this first list, L1, is going to be my x's. So I'm going to type in 1 and hit enter, and then 2, enter, 3, enter, 4, enter, 5, enter to get them entered in there. And I'll do the same thing with the y's. And make sure when you do the y's, since they're all negative, you use this negative. Don't use the minus button. Use this negative button. We're not subtracting anything. We're just saying that these values are negative. Okay? So -4, -2, -4, -16, and -44. Okay? Now I've got my XY table stored in my calculator. So now I want to do a regression, which means we're taking these data points and writing an equation out of them. Okay? So our standard form equation for a cubic function, I got a little ahead of myself here, but my standard form equation going to start out with a third term, x to the third term, and go down from there. And then we might have a constant at the end there. So my goal here is to figure out what a, b, c, and d are. Now I could use these x-y pairs and write a giant system of equations and do this by hand, but I'd much prefer to use my calculator because my calculator can do that pretty quickly. All right, so I've got that, that data in there. So now I'm going to go back to the stat menu again. You don't have to go to the home screen. You can go just hit the stat button again. We'll get to this same screen here, but we don't want to edit our list. What we want to do is a calculation. So go over to calc, and then we're going to go down and do a regression, and you need to find the right one. If it was first degree, I'd do a linear regression. Second degree is quadratic. Third degree would be a cubic regression. So we're choosing the cubic regression button here, just since it's third degree. So I'll hit enter. Sometimes you'll see a screen like this. Sometimes you want, yeah, I'm using those two lists. You can pretty much just go down to the bottom and hit calculate or hit enter a couple of times until you get to a screen that looks like this. And hey, that's what we wrote for standard form, but now it's telling me what the a, the b, the c, and the d are. So let's plug those in. A is -1, so negative x to the third. B would be 4x squared. C would be -3, so -3x, and then I got a -4 at the end. And there's a polynomial function that's going to fit all of those xy pairs. And you could always test it out if you had some time. Any of these xy pairs should satisfy this equation, right? So you could plug in 1 for x and -4 for y, and it should work here, okay? All right, let's try another on the next page. So I'm looking at these, okay, and my my x's are evenly spaced, right? So now I can test the y. So I'm thinking 99. It would have to be, I'd have to subtract something to get to 18, right? So just quickly, I could do 18 minus 99. Any number, subtract the previous number. So this is -81. 1 minus 18 would be -17. Makes sense. We'd subtract 17 right there. I'm going to subtract 1 here. We're going to add 39. And then, let's see, 214 minus 39 gives me 175. I better use my calculator because it's early in the morning. I make mistakes early in the morning. All right, so it's not first degree, right? So now I'm going to check second degree. So I'm going to think, okay, -81 to -17, I'd have to add something. But we can always do -17 minus the previous number. And that's, so we'd be adding 64, right? And to get from -17 to -1, we'd add 16. And then we'd add 40 to get from -1 to 39. And to get from 39 to 175, let's see, we'd add 136. Okay, so hey, this isn't second degree either, so let's keep going. See if it's third degree. Let's check the third differences. Okay, 16 minus 64 is -48. 40 minus 16 is 24. And 136 minus 40 is 96. Okay, so I'm running out of, this is narrowing down here. This is kind of the last test I can do because I need at least 2 numbers to compare. So it's hopefully it's going to be fourth degree because I know it's not first, second, or third. So let's try this out. 24 minus -48 is 72. I'd have to add 72. And then 96 minus 24 is also 72. We got a winner. Almost as if this problem were set up so that it would work like that and we'd have just enough data points. Okay, all right, so we've got a common fourth difference. That means it's going to be fourth degree. Okay, and that means it's going to be quartic. So you have to know that vocab because we're going to do a quartic regression now on our calculator. So you need to figure out what degree it is. Otherwise, you wouldn't know what type of regression to do on your calculator. Okay, and now just like on the previous page, I'm going to go to the stat menu to input. I'll hit edit, and then I'm going to input I'll clear out the lists I already have there, and I'm going to put in -2, -1, 0, 1, 2, 3 for my x's, for my y's. Okay, got them all in there. Once you get it all inputted, then I'm going to go back to the stat menu. I'll go over to calc, and last time we did cubic regression, but now I want to do a quartic regression. Okay, and just get past this screen, scroll down to the bottom, or just hit enter a couple times. And then we've got an equation in this format. It doesn't type out the whole, it doesn't show you the whole thing, but you get the idea there, right? So it's going to start with the a is 3, so that's for the x to the 4th term, and then b is -2, that's for the x to the 3rd. C is going to be for the x squared term, that's 5, and then -7x plus 1. So these numbers are the coefficients, and then the constant at the end. In the order they're going to appear in standard form. Okay. All right. So another way that you can sometimes write a polynomial equation is if you have some zeros, which are the x-intercepts really, right? But then you need another point as well. Now you could make an xy table out of this and try to do a regression like we just did using a calculator, but I'm actually going to do this without a calculator. Okay, so what I'm thinking first is that, all right, I'm going to write this in factored form. I'm actually not going to write it in standard form. So I'm going to have some sort of a number here, okay? And then I'm going to use these zeros. So I'm thinking, okay, if x equals -1 is a 0, then x plus 1 would be a factor, because a 0 is an x value that gives you a y of 0, right? So if I plugged in 0 for y here, zero product property would tell me x would equal -1, right? If x equals -2, then x plus 2 would be a factor, right? Because if this were equal to 0, then x would equal -2. Same thing with the 4, that would give me a factor of -4, okay? So I've almost written my equation now. The only thing I need now is the a value, okay? And the way I'm going to get that is by using this xy pair for my through point. So you want to use the point, I actually have 4 different points because this is -1, 0, -2, 0, 4, 0. But I want to use the one that's not an x-intercept, that's not a 0. And I'm going to plug that into this equation for x and y. So I'm going to put 12 in for y. I'm going to put 1 in for x. And there's 3 different spots to plug in my 1. Okay, and then I'm going to solve for a. I've only got one variable here, so let's see. 12 equals a times 2 times 3 times -3. So this would be 6 times -3. 6 times -3 would be -18. Okay. And then I'm going to divide by -18 to solve for a. Okay. Those would cancel. And so let's reduce this. I can see 6 goes into both of those. That would be -2/3 then if I divided by 6 on top and bottom. Okay. So a is -2/3. So now I can go back up here. I was only missing the a. And now I can just plug that in. -2/3 times x plus 1 times x plus 2 times x minus 4. Okay? Now that's not written in standard form. Maybe your teacher would want you to write that in standard form, and you could multiply it all out to put it in standard form, do some foiling and distributing the -2/3 and so forth. But I'm just going to leave it like that. Okay? All right, let's try another. Same kind of deal here. So I'm going to just kind of first set up what this would look like. I need to figure out what that a value is going to be, but I know I'm going to have x plus 3 in factored form and x minus 1 and x minus 2. Okay? So now I'm going to plug the xy pair in. This is the y-intercept, not the x-intercept, right? So it's okay to plug that in. I'm going to plug in 3 for y and 0 for x in all 3 x positions. Okay, and then The zeros don't do much, right? And then I'll multiply this out. So I've got negative 3 times negative 2, that would be 6. Positive 6, right? And then divide by 6. And a is going to equal 1/2. Okay? So now I can go back and finish this. I found the a value, right? So just rewrite that with 1/2 in the a position. Okay, that is it, and I will see you next time.